In this video, I'm going to be going over how to assign oxidation states when given a Lewis structure. So if we are given the Lewis structure, CH3COOH, we need to assign the oxidation states based on a given formula. The formula is the valence electrons for that atom minus how many electrons the atom has in the given molecule. So let's see how this comes into play. So if we want to assign the oxidation state for this hydrogen, we need to take one more thing into account. So in this carbon-hydrogen bond, this bond is made up of two electrons. So when we assign oxidation states using Lewis structures, we need to take into account that the more electronegative atom will take the electrons in a given bond. So the more electronegative atom takes all electrons. So carbon is more electronegative than hydrogen, so it will take both electrons. So we can now assign the oxidation state for hydrogen. Based on the periodic table, hydrogen has one valence electron, and in this molecule, it has 0 electrons. Both the electrons in that bond went to carbon, so the oxidation state is +1. We can assign +1 to each one of these hydrogens connected to carbon because the electrons in each of those bonds will all belong to carbon. So now let's assign the oxidation state for this carbon. Carbon, based on the periodic table, has 4 valence electrons. Now let's see how many electrons it has in this molecule. Well, it has 2, 4, 6. And looking at this carbon-carbon bond, we cannot say that either carbon is more electronegative, so 1 electron will go to each carbon, and we can say that this carbon has a total of 7 electrons for an oxidation state of -3. Looking at this carbon, we know that it has 1 electron. However, it is bonded to 2 oxygens. Oxygens are more electronegative than carbon. So assigning the oxidation state for carbon, we will see it wants 4 valence electrons. However, it only has 1 electron in this molecule. So 4 minus 1 is +3. Now, looking at this oxygen, oxygen wants 6 valence electrons. And in this molecule, let's see how many electrons it has. Well, it has 2, 4 from these 2 lone pairs, and oxygen is more electronegative than carbon, so it will take all of these electrons. So 2, 4, 6, 8 electrons. So it will have an oxidation state of -2. This oxygen right here also wants 6 valence electrons, and it has 2, 4, 6, 8 electrons. It is more electronegative than carbon and hydrogen. 6 minus 8 is -2. And this hydrogen wants 1 valence electron, and in this molecule, it has 0. It will be +1. Now, to check our work, we need to make sure that the overall charge matches the sum of our oxidation states. So CH3COOH does not have a charge. So we need to make sure that all of these add up to 0. So we have 3 hydrogens that have a +1 charge here, here, and here. That is +3. This carbon right here is -3, so that would put us at 0. This carbon right here is +3. These 2 oxygens are -2, which would put us at -1. And this +1 would bring us back to 0. So we should do that every time to check our work. And that is how you assign oxidation states using Lewis structures.